Hello and welcome to Math and Focus Singapore Math Student Edition Course 2A, Subchapter 1.1, Representing Rational Numbers on a Number Line. Okay, so friends, as you can see, this chapter has three basic things to understand. Absolute value, integers, fractions, mixed numbers, and decimals represented as m over n, and finally, rational numbers on number line. If you understand these three things, you can solve any sums, any problems related to these three from this chapter. So let's begin. First, we begin with absolute value. When we say absolute value, we mean the distance from 0. So on a number line, what is the distance of a number from 0? Okay, and I'm sure you know that distance is never ever negative, right? And that's what absolute value is about. So if you know this, absolute value is pretty simple. So what do you do here? So for example, 4. What is the absolute value of 4? To write absolute value, you always put numbers between these two bars, okay, to say that we're talking about absolute value. So absolute value of 4 is 4, right? If it is minus 3, right, we said it can never be negative, right? So absolute value of 3 minus 3 is 3. So for example, 0.5. That is 0.5. So absolute value is that is all. Okay, it's simple, right? Let's move to the next part. Integers, fractions, mixed numbers, decimals as m over n. First, let's understand this m over n. What do we mean by that? We know that this is a fraction, right? So m represents numerator and n represents denominator. So it's numerator over denominator, right? So numerator is the top part and denominator is the bottom part. Okay, so this is what we need to have in this part. So we begin with the integers first. Let's take an example of 4. How do we write 4 as m over n? That's numerator over denominator format. We have numerator, but what about the denominator? What do? We all know that when you divide any number, okay, any number x by 1, the answer is the number itself, right? This is the answer. So 4 divided by 1 is 4. So to represent integer as m by n, we simply divide by 1. Okay, if it was negative, minus 3. Put 1 over here. It's that simple. Okay, let's go to fractions. We know that fractions are already in the form of m over n. So what are we supposed to do here? Well, you just need to simplify the given fraction. Okay, when I say simplify, I mean to say that get it in its simplest form. How do we do this? Let's understand with an example. 125 over 20, right? This is equal to, do you know what is 125? What are its prime factors? Yes, 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125, right? And 20 is 5 times 4. If we cannot do this orally, there's no problem. We have a method. So let's have a look at this method. 125, and this is how you write it, right? So now the number ends with 5. You know the divisibility test for 5, right? Any number that ends with 0 and 5, we use 5 as a divisor. So we put 5 here. 12. So it's 2 times 5 times 2 is 10, right? And this is 12. So we have 2 here carried forward. Then 5 times 5 gives 25, right? That's 25. 5 again, 5 times 5, and this is 5 times 1 gives us 5. So that's how we have this 3 5s over here. Now we divide or we remove the common factors. So one is this 1 5 and this 1 5 gets cancelled. Remember, if you cancel ones in numerator, you cancel ones in denominator. It's not that there's 5 here, you cancel all the 5s, okay? As each number that you cancel in numerator should be cancelled in denominator. Every number cancellation should have a correspondence, okay? So not just randomly you do that. So this becomes 5 times 5 is 25 over 4. So this is your simplest form, okay? If you divide this further, you'll get decimal format, right? And that's what we are looking for. We are looking for m over n format. This cannot be further divided as a proper way as you did it here, right? So this is what you need to do with fractions. Simplify, simplest form. That is until it can't be further divided. Next is mixed numbers. What are mixed numbers and how do we solve them? So let's take another example. 3, 4 over 5. Okay, so this is not 34. Okay, this is 3 and then 4 over 5. So basically this is just a fraction format and this is just an integer here, right? But we write this is a mixed fraction and this is how you write it. To solve this, let's label as we go this way, okay? A, B, and C. So this is A, this is B, and this is C. And the formula is AC plus B over C. AC, right? Meaning A times C. So that is 3 times 5. B is 4 and 5. 3 times 5 is 15 plus 4 over 5. That is 19 over 5. This is how you convert a mixed number into a fraction. So this is your m upon n format that you want, right? Only thing is this formula. AC plus B over C. Okay? Air conditioning, for instance. Try and do this kind of things with formulas so it's easier to remember. Air conditioning. Okay? AC and B is already here, so put B here. C is down, you put it here. It's only A and C that gets multiplied, and remember this plus sign. So let's say this formula twice so that we remember it. AC plus B over C. AC plus B over C. That's simple. Done? Okay. Let's move to the next part, decimals. Decimals. 0.4 is a decimal, right? How do we get into m over n format? Do we do the same thing as we did here? Like put 1, so 4. Yeah, but this is still a decimal here. We don't want a decimal there, right? So what do you do to convert a decimal into an integer? So if it was 0.4, won't you time it by 10 to give you 4, right? So this is m, our numerator, right? So whatever you do in numerator, so you timed it by 10, right? So you put your 10. So this is, and you put 10 here. So that's it. Or the other way is, how many decimal digits do you have? After decimal point, how many digits do you have? 1, right? So it's 1 0 here. So if it was 0.04, so you write it 4, and you see how many digits? 2 digits. So 1 0 0. Okay, so either this way or this way. I think this is the easiest way. You just count the number of digits after decimal point and you put that many zeros after 1. So if it was 0.0004, so this would be 4 over 1 2 3 4. 1 2 3 4. Simple. That's how you get m over n format here. So let's move to the next part now, which is rational numbers on a number line. What do you do? How do you do it? So for example, you want to represent numbers like minus 1.3 or minus 2.5 or a number like 2.2 or 3.3 on a number line. So how do you do that? You need to use your scale and your pencil, right? So let's draw here. So I see my measurements as the biggest number here is 3.3, and this is 2 minus 2.5, right? So as I draw here, I'll say, for example, this is my 0 here. Each centimeter for me represents 1 unit. This way, I'll make it easier for me to mark my numbers, okay? We need to be smart, right? So it's easier for us to put them on the number line. So this way, do you see this tiny marks here between 1 centimeter? Those becomes my points. So if I want to mark, so for example, as the scale says, this is 5, I want to mark 5.5. I know this is 5.5. If I want 7.7, I know that 1, 2, 3, 4, 5, 6, 7, 7. So this is where it will be, right? So it becomes easier. So this is your 0. This is 1. This is 2, 3, 4, right? And this side, it's minus 1. Yes, minus 2, minus 3, and minus 4. Okay, now you have 2.2. So this is between 2 and 3. So let's take our scale. This is 1 centimeter, each point representing here point. So 3.3. So I'll take 3 points, right? 3 is here already. 1, 2, 3. So this is where my point is. So this is 3.3. 2.2. So it's between 2 and 3. So 2 and 3 is here. So 1 and 2. So this is again 2.2. 2.5 minus 2.5, right? So I'll go towards minus side now. So this is 2 and it's between minus 3 and minus 2, right? So here I put my scale, and this is 5 units here. So this is minus 2.5, minus 1.3. So between minus 1 and minus 2, right? So 1 and 2 here, and I put count 3 units. Here is my 3 units. So this is minus 1.3. So this is how you put them on the number line. For example, if you had numbers like 10, 20, 30, minus 50, would you then take 1 centimeter as 1 unit? Of course not, right? Then in that case, we need to have our units bigger here. So let's draw again a line here, right? So what are we going to do? Let's say this is our 0, okay? Now here, each centimeter I'm going to take as 10 units. So this is 10, this is 20, this is 30, this is 40, this is 50, right? So that way you go, and it's easier than 10, 20. So you had 25 to mark. So then between 20 and 30, you take this, and this becomes 25, right? So it's the whole objective here is that you decide the units based on the numbers that you have to mark. If the numbers are small, you take 1 centimeter as 1 number, right? Here the numbers were too big, so I took 1 centimeter as 10 units. So it's just understanding that and deciding your number line. So this chapter is done. The 3 things that we need to do here are pretty simple, straightforward. So it's the absolute value, as we said, which is never negative. It is always positive because distance is never negative. Then we saw how to convert integers, how to convert fractions, mixed numbers, and decimals into m/n format, right? Do you remember this formula? Yes, let's say it once. AC plus B over C. Okay? And finally, you have this rational numbers here on the number line. So you decide your scale based on the units that you need to mark. Okay? So this is all about this chapter. I'm sure you understood it well. Even then, if you have doubts, questions, queries, you can put them in the comment section. I will try my best to answer them and help you as much as I can. Also, you can watch out other videos that helps you understand other chapters in detail, and also the independent exercises for each of these chapters. Thank you very much. Enjoy your studies, have fun. Remember, math is fun, okay? Bye bye.